You want to test the claim that the average lifespan of a cricket is at least 88 days. Luckily, you're doing so well in your stats course that you can take some time each day and watch your collection of crickets. You carefully watch 14 crickets, find the average lifespan, and calculate the test statistic as t equals negative 2.621. Find the p-value of this test statistic. Now the first thing I'll do is find what kind of test, left, right, or two-tail, this is. There's a hint in the critical value, in the test statistic rather, which I'll mention in a moment. So the first thing, write down the claim. The claim is at least 88 days. So the mean lifespan is at least, meaning greater than, or could be equal to, 88. The opposite then is less than 88. Now the one with the equal sign corresponds to our null hypothesis, and there we change it to equals. Mu equals 88, and the other one without the equal sign becomes our alternative hypothesis. No change to the symbol. The alternative hypothesis tells us that because this is a less than symbol, we have a left tail test. Now, when you have a left tail test, you should have a negative test statistic. If you have a right tail test, you should have a positive test statistic. If you have a two tail test, all bets are off. It could be positive or negative. But when it's a negative test statistic, we want to find the area to the left into the tail. If we had a positive test statistic, then you find the area into the right tail. And then if you know it's a two tail test, then you just double that area. In our case, left tail test, negative test statistic, we find the area to the left. So I know my test statistic is here, negative 2.621. I'm going to find the p-value in two ways. I'm going to look it up on the t-distribution table, but there we'll only be able to get a range, not the exact p-value, which is usually good enough, which you'll see when we start doing hypothesis tests fully. But if I want to be more specific, then I'll go to some sort of technology, in our case, the spreadsheet, which I'll show you in a moment. So we'll need to know what the degrees of freedom are. In our case, so n minus 1, our n is 14 because of our 14 crickets in our sample, and that gives us a degrees of freedom of 13. So a couple things to keep in mind as we go to the distribution table. We've got a degrees of freedom of 13. I've got t test statistic of negative 2.621, and it's a left tail, more specifically, it's a one tail test. So go to my t distribution, find the row 13, my degrees of freedom, and now I'm going to look for my test statistic, which was negative 2.621 in that row 13. But notice these are all positive values. So what I want to do is, just for a moment, imagine that my test statistic is actually positive 2.621 and compare it to these. So I know that it is less than 2.65 because I have 2.62, but it's more than 2.16. So that means my test statistic would be somewhere in here, at least the positive version. And that means my p-value is going to be between these two values. And I'm specifically looking in the area in one tail because this is a left tail test. If this was a two tail test, then I'd be saying my p-value is between 0.02 and 0.05. But as it is, left tail test, my p-value is between 0.01 and 0.025. Now most of the time, getting a range like that is going to be enough. But if we need a specific p-value, like we do on a lot of the homework questions, and this one in particular, I can use a spreadsheet. So I will come over to a spreadsheet and use the equal t.dist, t.dist. There is a t.dist, but it works a little bit differently than what I'm going to do here. So now if I type in negative 2.621 as my as my test statistic, and degrees of freedom was 13, and I know this is a one-tail test as opposed to a two-tail test, so I plug in 1 there, I'm going to get an error here. Because if you look at this error, it tells me that one of the parameters is negative, it should be positive or 0. This t-dist function only likes positives. So just like on our t-distribution table with only positive values in the table, this t-dist function also only likes positive values. So as long as we keep in mind that we're dealing with a left-tail test, there's no harm in using the positive version. And that gets me 0.0105, or rounded up actually to 0.0106. So my p-value is going to be 0.0106. I'll just abbreviate this as p-value is 0.0106, which is indeed greater than 0.01 and less than 0.025.